Oturum kaydediliyor diyor. Şu an.
Kaydediyor. Sonra izleyebilirsiniz yani. Kaydedeceğiz. Siz de kaydedin. 45 dakika 45 dakika önce. Kaydedin. Başka yerden şey yaptı herhalde. Neyse nasıl yapabiliyorsa öyle yapsın ya. Sorun değil. Belki ekranında o çıkmadı bilmiyorum. Moderatör gözükmüyor. Tekrar çıktı herhalde. Çıktı. İnternet çekmiyor galiba.
Neyse,
Burada ben telefonla arayayım da ben WhatsApp'tan arayayım da şey yapayım. Sorunu çözelim çünkü.
Oturma katıldı diyor.
20 geçe. Programda kaç gözüküyor? Sizde de vardı yani. Programa bakar mısınız? 20 geçe diye hatırlıyorum.
Alo.
Hocam merhaba. Siz tekrar çıktınız herhalde. Tekrar ben sizi şey yapayım. Moderatör yapayım. Şifreyi hatırlasaydım size verilen orada direkt yetkili var da neyse anlatmak lazım. Size biz devamlı kullandığımız için biliyoruz yani. Şimdi hocam siz moderatör oldunuz. Ekranda sağ alt köşede mor bir şey vardı. Turuncu mor işte. Konuk olarak zaten katıldınız. Ben sizi şey yaptım. Bu şeyden girmişsiniz. Katılımcılara gönderdiğimiz linkten girmişsiniz. Sizin şifrenizden girseydiniz şarya gibi sorun yoktu da. Burada da sorun yok. Biz de şey yapmamız gerekiyor. Sizi moderatör atayalım.
Şu an girdim ben.
Şimdi moderatör olarak atadık şimdi hocam. Tamam. Niye? Bir dakika. Şimdi moderatörsünüz hocam. Şimdi sağ altta turuncuyu tıklayınca ekranda bir şeyler gözüküyor. 3 tane şey. Birisi sohbet. Orada açtığın zaman sağ altta şey var. İçerik paylaş var yani üzerine getirince mouse'u.
Hocam şimdi çıkar.
Çıkmıyor mu?
Hocam yeni oldunuz. Şimdi çıkabilir hocam.
Şimdi çıkabilir. Biraz bekleyin yani. Biraz bekleyin 1-2 dakika.
Moderatörler deyip yazıp çıkarma oradan.
Tamam. Şimdi hocam şimdi deneyin. Birdenbire oluşmuyor. Moderatör yeni atandığı için. Şimdi içerik paylaş çıkması lazım. Tekrar deneyin. Başka yere tıklayın. Tekrar buraya tıklayın. İçerik paylaş o aktif hale geldi mi hocam?
Yok gelmedi henüz. Herkes moderatörler sohbet dikkat var.
Moderatör olmadınız mı? Moderatör
da olmadım ki ben. Buradan bir problem var.
Şimdi kişilere başladığın zaman moderatör gözükmüyor mu? Bende moderatör gözüküyorsunuz.
Hayır.
Başka yere bir tıklayın. Sohbete tıklayın. Sonra içerik paylaşa tıklayın. İçerik paylaş çıkmadı. Çıkması lazım ama.
Allaberen hocanın 4 yazan moderatör oldu. Diğerleri değil belki.
Kaç tane var ki? Başka yok ki.
2, 3, bir sürü bir.
Onlar etkin değil. Şimdi ekranda çıkmadı mı hocam? İçerik paylaş sağ altında.
Hayır.
Ben yapmayacağım ben.
O zaman şey yapalım. Sen şeyle gönderdin. Tam metin gönderdin maille onu mu girelim?
Girebilirsiniz o metni.
O metni bu sabah gönderdiğiniz metni o zaman şeye yükleyeyim ben şimdi.
Yükleseniz o zaman ben onun üzerine konuşurum.
Tamam öyle yapalım. Dur hocam. Hangi maile geldi? Hangi maile gönderdiniz hatırlıyor musunuz? AIP'ye gönderiyoruz.
Çağrı'nınki de var.
Bir dakika buluyorum yani. Benim 8 tane e-mailim var da. ICMS'ye mi gönderdi? Ona değil. IP'ye gönderiyorsunuz genelde. Her çakallı IP var bir tane. Tamam bir bakayım burada bu. Buradadır siz buraya. Tamam. 123.pdf değil mi hocam? 123.
Aha, o.
Tamam. Oradan indiriyorum. Tamam. Şimdi ekranda görürsünüz hocam. Şimdi görüyor musunuz dosyayı?
Ha gördüm
Şimdi görüyor
gördüm
musunuz?
gördüm gördüm.
Ha, bunun üzerinde hareket ettirebiliyor musunuz? Biz mi hareket
Bir dakika
ettirelim?
ben bununla birazcık şey yapayım da ben.
Ha, biraz bakın hocam. Onu da bir sorun olursa söyleyin.
Oldu bak böylece bu şey olsa yeter. Bunun üzerine gider mi?
Siz ekranı büyütebiliyor musunuz ekrandaki şeyi? Ben büyüt.
Benim bu kadar büyütebiliyorum. Bir dakika şunu da ayırmaya çalışayım. Aha.
Yani bu ekranda şey yapamıyorsanız bunu şey yapacağız. Ya ben ya bir arkadaş diyeceğim indirecek.
Bu nasıl şu an büyük mü?
Büyüklüğü nasıl? Ben büyüttüm. Siz de büyütebiliyorsunuz herhalde.
Yok ben büyüttüm şu an. Nasıl siz görüyorsunuz?
İyi gözüküyor yani. A note on the telegraph type differential equation with time involution hocam.
O zaman başlayayım mı ben?
Hocam programa bakarsak program daha olmadı. 10.20'de değil mi hocam? 10.20 geçiyor hocam programda. Çağrı hocamın programında da yazıyor.
O zaman
Bütün
o zaman
seçimlerde.
o başlarsa ben yine de yazıp uğraşayım belki de
Başarılı.
kendim
25 dakika var yani.
aha o
Yani
zaman
çabuk-
problem yok.
Ha, çay mı içelim dışarıya da bir pasta börek gelmiş. Siz gelmediğinize üzülmeyin.
Olur sağ olun.
Hadi görüşürüz hocam. Sesi kapatıyorum. Rahatsız etmesin sizi.
Arya.
Alo.
Çağrı'ya girdin mi moderatör ol?
Ha, girdim aha.
Ben şeyini o mouse alın collaborate panel kapat diye.
Aha.
O kapatmalı değil ki. Aç demek lazım. Orada kapat deyip çıkıyor. Şimdi aç deyip
Yeni
çıkıyor.
moderatör yapıyorum.
Collaborator panelini aç diye.
Şu an moderatörsün.
Aha, artık moderatörsünüz diyor. Şimdi ne etmeli? Collaborator panelini açıp dosyamı ne etmeli mi?
Aha. Üçüncüsünde şeyle yön var, içerik paylaş diye.
İçerik paylaş eğer çıkmadı ki. Şunu inni çıktı. İçerik paylaş çıktı.
Aha.
Birinci
Yeni
içerik diye.
standart her şeyini eskisi gibi yapacaksın. Zoom'daki gibi.
Yo, bu yerden
Bilgisayardan bir şey
yani
ekleyebilirsin.
bile bak. Zoom'da paylaş var. Bir yerde paylaş yok.
Yok.
Dosya paylaş diye.
İkinci var. Uygulama ekran paylaş. Dosya
Uygulama
paylaş
ekran
var.
paylaş. Aha.
Uygulama ekran paylaş. Tüm ekran.
Aha. Paylaştırılacak bir çekme seçin diye.
Paylaş. Anlamadım.
Paylaşılacak bir sekme seçin.
İkinciye gel. Uygulama paylaş. Ekran paylaş diye. Birinci
Uygulama
içerik.
ekran paylaşa geldim mi hemen?
Birinci içerikte mi?
Birinci içerikte o.
Uygulama
Ekran paylaş.
Chrome var, pencere var, tüm ekran
Chrome
var.
çekmesi
Tüm
var.
ekrana basarsan
Pencere haysi birine.
pencere değil. Sağında tüm ekran var.
Tüm ekranı.
Şimdi paylaş.
İnni paylaş. Doğru hadır. Yakacağım paylaş diye.
Aha, şimdi geliyorum. Aha, geldi.
Geldi mi?
Aha.
Hadır. Bir dakika. Bu bir yerden der. Şu gelmedi de. Bu ne için böyle vallahi bu?
O başka pencerelere geliyor.
Dur. Hadır şunu yerden çıktı. Şunu yerden çıktı. Hadır bir
Şu
bakayım
var.
bir yerde bulmalı olur. Şuların hepsini yapayım. Şuların hepsini yapayım. Hadır. İnnem paylaştırma durdur deyip yeni tezden gireyim.
Yeniden bir bak.
Uygulama
ekran paylaş.
İlk birini ben yükleyin ben makalani sunum yükleyin doğru. Yükledim. Hazır sunumu yükledim ben. Yemeğe geleyen şu yerden ekran paylaşım neredeyini yine uygulama ekran paylaşıma geleyen tam ekran diyen onun
Tüm ekrana geliyor. Paylaş diye. Aha.
Şimdi tam ekran dedim mi?
Bilgisayarında işleverin mi? Bilgisayarında ne? Şu an geldi bak.
Geldi mi şu?
Aha, geldi.
Onda men dokla nemem tayin onunla çağırıyor. Şu an kov görünüyor mu?
Enot onze aha kayya şu vakt normal abstrakta
Bollu
geldi.
bollu şu. Şu kov görünüyor değil mi?
Aha normal. Oldu.
Aha oldu, sağ olun.
Sesimi kapatıyorum.
Aha. Benim sesim geliyor değil mi?
Dear Professor Allaberen, hocam hazır mısınız? Are you
Yeah,
ready?
you are. Yeah.
Professor Allaberen, everybody knows him from his publications, famous. He will give his talk now.
Okay. Thanks everybody participation in this conference. Thanks for organizing committee and especially Professor Dr. Hüseyin Çakallı for his a lot job. This activity start with 2009 and until today work it. So this is very important activity and also some activity with publication, Hüseyin Çakallı. So thanks for such type activity in Istanbul. Today, Hüseyin Çakallı give one more possibility for me to give a lecture as a special speaker here, and title of my talk on the telegraph type differential equation with time involution. Really, this work joined with my collaborators from young mathematician from Turkmenistan. So we start in this work initial value problem, telegraph type involutory with respect time, second order linear partial differential equation with damping term. The equivalent initial value problem for the first order differential equation to the initial value problem for this second order linear differential equation with involution and damping term is obtained. Applying operator approach, the stability estimates for the solution, and it is first and second order derivatives of this problem are established. So functional differential equation, which provide mathematical models for real valid problems, have been investigated by many sciences. Here, start with Harmander's work and Kalmanovsky, Mishkis, so Verduan. This is classical works. And one part, delay differential equation are universal phenomena applied their models engineering system to behave like a real process. Here also I give some reference about delay. Initial conditions in one point are not enough to get the solution of delay differential equation. In the first time, Clement Felfon, 2013, in an experiment measure of population growth for species of butterflies. He spent in this study, he tried to use a delay differential model. He clarified the form of population equation in one. The obstacle on this investigation was that he did not enough information about reasonable history function n of t on minus d0 to get solution of this problem. He reversed time to get the solution of functional differential equation, and he used a reversal in order to seek the population before this initial time t equals 0. This has been work 1997. And involutory differential equation is a type equation and the time reversal problem in special case from it. It is called involutory differential equation if it is involving unknown function y at t and d minus t. So Hesbit here consider delay equation changing t minus d with d minus t. And fall for call it such type equation idempotent differential equation, and later we understand really it is involutory, and here u square t equal t, not u cube of t equal t. So here two works about this subject and results in these models. Functional differential equation with involution has been studied in several papers. Here, one important paper, Kabade. Later I will fix it here. Lot investigation, also my group here. Investigation such type problems. So in the monograph Kabade, 2015, involution differential equation studies throughout the discourse related to Green's functions. They investigate the theory of Green's function for functional differential equation with involution in the simplest case. Order 1 problem with constant coefficients and reflection. Here, they solve the problem with different boundary conditions, studying the specific characteristics which appears then considers periodic, antiperiodic, initial, and arbitrary boundary condition. Computing explicitly the Green's function of the problem with non-constant coefficients is not simpler, not even in the case of ordinary differential equation. They presented a double trick. First, they reduce the case of general involution to the case of reflection. And then they use a specific change of variable that allows obtain of the Green's functional problem with non-constant coefficients from the Green's function of constant coefficients analogies. So this is really very important point for construction Green's functions when differential problem involves here involution. Our joint work with my colleagues, we first we consider boundless solution initial value problem 2. So today we will talk about telegraph. Really, our work starts with this work. Simpler case, ordinary differential equation, second order differential equation, as you see, damping term and involution term. Here damping term derivative t, involution term y u of t. So what does it mean u of t? U of t involution function. That means u of t equal t. Involution follows from this formula because u square equal 1. So t0 is fixed point of u and I all real line. Problem 2 does not seem yields directly from ordinary differential equation without involution term. So we need some construction like Kabade, second order differential equation. We will transform first order without involution, and after that return back. We constructed some function usually we will using here Green's functions techniques for solving formula for solution. So presently here many mathematicians interested with spectral equations, spectral problems for differential equation is involution. Here many investigation in this subject, and famous mathematicians worked in this area. Shkalikov, Turmetov, Sarsenbay, a lot, Karachuk, so many mathematicians. In the paper Sarsenbay, a definition of Green's function of the general boundary value problem for non-self-adjoint second-order differential equation with involution was given. The sufficient condition for the basis property system even functions are established. In the terms of boundary conditions, uniform equiconvergent spectral expansions related to the second-order differential equation with involution equation number 3 with boundary conditions like Dirichlet boundary conditions. No, not Dirichlet. Here third type problem. Y prime minus 1 plus b y minus 1 equals 0 and y prime 1 plus dy 1 equals 0 is obtained. Direct inverse problem, hyperbolic, parabolic equation, differential and difference equation studied many mathematicians. Here we give some papers in this area. So delay hyperbolic and telegraph differential equation has been studied several papers. Our paper and Zhang, Prakash Takshman, and here many mathematicians also worked in this area. Partial differential equation with delay and involution terms have deeply different property of solution when without involution terms. But our investigation, my master student Abdul Muhammad, here we will consider really we have different property second order differential equation with involution, without involution. So we need study here separately all these subjects. So the main aim of this work to study stability of solution initial value problem, telegraph type involutory partial differential equation for here given functions, smooth functions and bounded, and we will find here conditions such that guaranteed bounded solution stability properties problem 4. This is absolute volume B less than A, and for A we need put some conditions. So problem 4 can be write abstract initial value problem 5 in Banach space Ci of all continuous bounded function f of x defined on I with norm, supreme norm. And we introduce here second order differential minus second order differential operator with a corresponding domain in CH, and using here abstract way later we will consider here getting some formula for solution using by operator techniques, and in here in first 4 G of t really and U of t, noun and unknown abstract functions with value c, e, and phi and xi unknown elements, and c1 I all continuous real function f of x, and norm defined by formula 7. And we will formulate the main theorem. Assume that 8 conditions satisfied. Let g of t smooth and bounded function I, and here also we need some smoothness property as shown here, and really smooth with respect t, and also must be from domain of A. That means smoothness property with respect x also. Then problem 5, equivalent the following initial value problem. So as you see here, problem again initial value, but now first order differential equation. First order differential equation. Why it is important? Because here without involution, now U of t here depended only t, not here minus t arguments terms, who depended with minus. So now about equivalence. So what do? Differentiation of equation 5 with respect to t, we get formula 10 and 11. Really, this is formula for third order derivative and first order derivative. And using this equation, an initial condition, and equation for in problem 5, we get 12 initial value, but this is first U0 phi given, U prime c, and volume of second order derivative, third order we can find. Now putting minus t instead of t, equation 5, we get formula 13. Now applying equation 5, 11, 13, we get now directly first order equation, not involving minus t arguments. So our problem now, we must prove another side. First, our problem equivalent to the initial value problem first order. Now we will prove why it is really equivalent. We will introduce L of t by formula 13, and we will prove LT solution of 15. I would like to draw your attention here, right side 0, and initial data also 0. But this is homogeneous equation, and from that it follows LT equals 0. So theorem 1 to 1 proved. Now we will obtain solution of initial value problem 9. It is easy to see that first order differential equation we can write as a system of second order differential second order differential equations. But as you see here, this left side we can write as a product. So this is directly initial point for getting such type system 16. So as you see here, we have two equations second order for U of t and V of t. Right side f of t defined by given data g of t, g minus t, first order derivative and second order derivative g of t. Linear combination, such type of given functions. And V0, here we have also terms corresponding phi z, but and also g0 and g prime 0. So now return back. We can problem find, write, and as a normal system system hyperbolic equations. As you see here, 17 system of really I write here telegram, but as you see here, hyperbolic special case of telegraph. Easy for investigation because directly we can using here D'Alembert's formula. So first we write formula, D'Alembert formula for U of t. It is easy, but for V of t also we will construct it vector. But now initial data on right side generated by given data, linear combination of given data and their derivative. So, and now using this formula, we can write formula UT directly 20, formula 20, and as you see, this formula involves several terms, such that involves initial data vec c and also derivative here and right side and g and derivatives. So and here theorem 2.2 assumes that condition for coefficients satisfied. Let GTX be smooth and bounded function I product I, and here GTX, G prime t, GXX tx at GTX belongs to C1 II and phi XX CXX belongs C1 II, and condition for right side and inertial functions 21 satisfied, 21 and 22. Then for the solution problem 4, we have following stability inequality. As you see here, we get stability inequality for the solution, and right side here PXC, and also some agreements we need Y condition 21 and 22. And this is first statement, and later 24 stability inequality first order derivative with respect t and with respect x. So 25 this is real stability inequality all second order derivatives. This is with respect t, with respect x, and also mixed derivatives. So now a little bit more about construction solution. So we have formula for UTX. It is J1 constructed by phi and xi, and G2 TX constructed by their derivatives, as you see, and G3TX also here under function with respect xi derivative, here with respect lambda derivative xi. So all these terms really we need under the some condition some with respect xi and phi, but main difficulty G4TX. this is really right here. If R lambda from right side now differential problem, and we will estimate these all terms separately. First, about stability inequality for the solution. It is based on the following inequality for the solution. But here, first we need to estimate G1 26. About G2, we need some computations, and 28. And G3 also we need some transform, and using triangle inequality we get 13. And 4, as you see here, difficult part, and we need more computation, but main last estimate 32 here for G4. And combining these estimates, we can get a formula for solution stability inequality 23. But stability inequality 24, it is stability inequality first order derivative. So using this construction formula for solution and getting a derivative, we get now corresponding inequality 35 now for G1 and 38 G2 and 31 for G3 for first derivative respect t and first derivative respect x, and later G4 for G4 for 34. And using all this estimate, we get estimate for the first order derivative. Later we will prove estimate for the second order derivative. So for G1 estimate 35 here, and for G2 like that, and G3 46 and last 49 for the G4. And combine all this estimate, we can find stability inequality for the second order derivative, our solutions. So now about ending part, conclusion and our future plans. In this study, the initial value problem for the telegraph type involutory linear partial differential equation is investigated. The equivalent initial value problem for the first order linear partial differential equation to the initial value problem for this second order linear partial differential equation with involution is established. Applying operator tools, the stability estimate for the solution and it is first, second order derivatives of this problem are proven. Note that using this method, we can get similarity statements for the solution of following problem 50 for the multidimensional telegraph involutory partial differential equation and under the smooth condition for given data. But our problem, and here 50, all this problem with constant coefficients. Why? Because we need some techniques for getting formula for solution, operator techniques plus formula like D'Alembert. So classic techniques. But our plan is in future investigate the stability of the initial problem 51 in a Hilbert space H with self-adjoint positive definite operator A. This is, as you see, second order differential equation with damping term and also involution and unbounded, arbitrary unbounded operator A. So operator tools important to getting stability when coefficients dependent variables, and also there is some possibility getting same time simple results from one-dimensional and multi-dimensional problems. So only we need study here property of space operator. But as you see here, we consider telegraph or maybe hyperbolic, but classic hyperbolic, a parabolic. It is important construction absolutely stable difference schemes. Why? Because usually hyperbolic equation, we need some relation, current type relation for getting stability. So and all time we need constructed here absolutely stable difference schemes, and future we will think about construction and investigation high order accuracy stable difference schemes for the numerical solution initial value problem with damping term and involution. Here I think literature 50 important for study such type problem, because this techniques useful for getting such type study. And study high order accuracy uniform two-step difference schemes and asymptotic formulas for the solution of the initial value problem 52 in Hilbert space H with self-adjoint positive definite operator and with epsilon small parameter multiplying term is a time derivative term. So we have here second order main high order derivative small parameter, and study such type problem without involution. We have one paper joined with Hector Fattarine really many long time before during my stay in USA. So these techniques I hope may be helpful for getting results about uniform difference schemes and also asymptotic formula for the solution. So thanks for your attendance. If you have question, I try to give answer. If you're interested, it will be better to listen you. Okay.
Thanks to Professor Allaberen. Is there any questions and comments? Thank you very much for your valuable talk. Thank you. Now, from now on today, in the sessions, talks will go on. In some sessions, talks began 11 o'clock, 11:30, a quarter past 11, and in some sessions afternoon. At 12 o'clock, between 12 and 1, you can have your lunch at the building, Cultural Center building, ground floor. And we will be somebody, I or somebody else will help you to enter the entrance point. In this hall, analysis and functional session will go on in this hall. The others in all numbers given on the notices.
Robin Ersin. Bakın,